Hi, my name is André Martinez. I'm a PhD student in the college program at the University of Campinas and the supervisor of Professor Matia Pires. Today I'm going to be presenting a work called Reevaluating Species Topological Importance in the Largest Neotropical Seed Dispersal Network. When working with interactions, sampling then requires many observation and can be something pretty hard to do to get good information about when the interactions are truly happening. Many interactions can pass unnoticed even if good sampling due to temporal and spatial mismatches and problems related to their abundance. To help solve this problem, probabilistic models can help as they work. They can estimate the interaction probability between two species just with some information about the frequency of interactions that are happening and the traits of two species. Then we can use them to better understand the role of each species in the CIDR community as we have a better overview of how those interactions are happening. In our work, we developed two probabilistic interactions models using the data from Atlantic Frugivory database, which is the largest database for frugivory in the neotropics, as far as we know. But we are more interested in the seed dispersal side of the interactions. So we filtered choose interactions here, as they are from frugivory, to get only the ones that can be classified as possibly true seed dispersal, where this bird actually ingests the whole seed. And then we selected inside the choose interactions the ones that were better sampled to use as input for our models. First, the model that we developed was a trait matching model that used the trait of the bird here, the gate size, the seed trait here, the seed size, and the interaction frequencies that were sampled. Together, we can use choose information to develop a probabilistic model, as represented here for each species, that gives us the probability of the bird interaction with each species of plant. We then compare this information that the model gives us with the one that was sampled, choose which one is higher, and then we use that to reconstruct an interaction matrix that has more information than the one that was just sampled. Another possibility is trying to use the phylogeny to assess this trait, as can be pretty hard to get the trait information for each species. So we select some species that were well sampled and for which we have a good amount of information, and we use a singular value decomposition. That's a technique to reduce the dimensions of the matrix to estimate latent traits for each species. We use these latent values as traits, as if they are traits for the species, and using an evolutionary model, we can try to see the evolution of these traits in a phylogeny to estimate the values for other species that we are interested but we have no information about. With this, we can do the inverse process and reconstruct the matrix with the species that we are interested but we didn't have the information before. Doing so resulted in us having choose two networks. Here you can see the gray links represent the ones that were in the database prior to our models, and the blue ones is the ones that our models estimate. And you can see the models estimate a lot of interactions that weren't present before on the database. As you can see here in this degree distribution, all the species get a huge improvement on their degree used in both models. Even species that used to have 1 or even less than 10 interactions get much more when we apply these models. And both models have a good ability to correctly predict the interactions that were there before. Especially the trait matching model, is performing even better than the latent trait model, but latent model has potential if you're looking to species that are closely related in the phylogeny. With both of models change the topological importance of these species when you consider the interactions they predict, as they get 10 times more interactions, which change the connectance of the whole network as well its modularity and its netness. So using choose models, we get more realistic networks, and they help us show that we may be underestimating the relevance of some of the species as seed dispersals, as they may interact with much more species than we are able to observe if you just use the sample data. We would like to thank ATBC for letting us present our work today here, CAPS for the scholarship grant, and Unicamp and the postgraduation program in ecology for the structure on using this work. And thank you as well for paying attention to our work today.